My name is Ross Greer, and I am presenting on Salient-Sensitive Sign Classification in Autonomous Vehicle Path Planning, Experimental Explorations with the Novel Dataset. We define a sign to be salient if the visible sign provides an instruction intended for the ego vehicle location before the next decision point, independent of the actions of other agents and instructions provided to other lanes. First off, we have a complex traffic scene shown in this montage, and there are many signs detected. The question we seek to answer with the property of sign salience is which signs help you from the position of this vehicle to safely navigate the complex intersection. Similarly, we can ask, are all detections equally important? In this scene, there's a stop sign, which is for the imminent stop for the lane that we are in, and there's also a speed limit sign for the cross traffic. And we would argue that the stop sign is much more important, and the model should be able to take this into account when doing path planning and even when evaluating its own performance on sign detection. In this next slide, we ask, is the closest or most visible sign necessarily relevant? The sign on the right says right lane must turn right, but we're not in the right lane, so it's not relevant to our path planning. However, the further sign, which is actually smaller and less clear to see at the upcoming stoplight, is a sign that directs the flow of traffic for the lane we are in. Finally, we have another example asking, is the closest or most visible sign necessarily relevant? In this case, we have a speed limit sign which is located in a position that is typically informative to the lane we're in on the right, but the speed limit doesn't apply to our lane since we're on a freeway and that sign is for the exit. So in this case, there's additional information in the sign, such as its color and its location compared to lane markers, that indicate that it's not necessarily relevant to our vehicle. And in fact, if we followed that instruction, we would create an unsafe scene on the freeway. So to this end, we introduce the LAVA dataset for salient-sensitive traffic signs. And we point out in the feature set that ours includes a new feature that is not included in other datasets for sign salience. This is a binary marker to indicate whether the sign is salient or not in the given frame. So the next thing we do is we explore the data that we create in this dataset. And as a baseline to decide if we're actually doing any improvement in our learning methods, we start with a trivial classifier, which asks, is the sign located right of center of the vehicle or left of center? If it's right of center, this is where we would typically find signs which are informative to our vehicle path, so we would automatically regard this as salient, and if it's left of center, we'd regard it as not salient. We then improve on this using a ResNet 50 classifier, where we say, instead of using just the location of the sign, let's take the image data itself and look at the sign, noting that the way the sign is shaded or the angle in which it fills its crop. This can indicate things such as the size of the sign, its location relative to the vehicle, perhaps the angle it's located relative to the vehicle, as well as the type of sign, since some signs tend to be more relevant than others, or more often classified as salient. To build further off this classifier, we then add some augmentations. We could add the intended vehicle maneuver, such as going forward, turning right, turning left, stopping, then turning, since this would bring out certain signs as becoming more relevant. We can also augment with the location of the sign in the frame, since this can be used to infer the distance to the sign, as well as its position relative to our lane, since perhaps a sign that is far off to the right, too far off and too small, is probably for cross traffic or a different scene that happens to be captured by the camera. Additionally, we can add the type of roadway because the roadway type could inform what signs you could expect. On a freeway, you might not expect a school zone sign to appear, and when you're in a residential area, you might not see speed limit 65. So knowing the roadway type could inform whether the sign we're seeing is actually a salient member of the scene. And some of the patterns we find in our scene are shown here. So in general, looking at the middle column, most of the salient signs are located on the right side of the vehicle, as we would expect. Which isn't to say there aren't some located on the left, but just as a prior, they're more often on the right, whereas the non-salient signs tend to be more uniformly distributed across the field of view. The location of signs which are salient actually varies based on the scene type, so this joint information could be used to better inform the model. And as we see, the maneuver augmentation actually showed the best performance, reaching near 76% accuracy. In our future work, we would like to perform more experiments and ideally collect even more data. We'd also like to take the sign salience property itself and transform it over time from a categorical, in this case binary, property to something more continuous so that we can make rankings between scenes or even within a scene as to how important certain signs are and create an order to them instead of just an on-off property.